If you're designing a new product, using 3D renderings early in the process is a great way to get feedback, clarify what's needed, and make improvements before you even start prototyping. Blender is a great tool to make those renderings, and in this video, I'll show you the basic features so that you can quickly get started and make such animation for your own products. So let's jump in. When you first open Blender, you see a default scene with a camera, a cube, and a light. To start, you may find useful to adjust the interface scale in the preferences to better identify icons and navigate the different tools. We'll use the cube later, so I am not deleting it. I'll just move it for the moment and import the tempering machine which was exported from FreeCAD as a GLTF file. It is placed at the origin and we can now get a sense of the grid size. It is 1 meter and the tabletop is 70 centimeters by 1.2 meters. We can check this in the Item Transform menu that you can open by clicking on the side arrow in the viewport or by pressing N. We can also check the default cube size and see it is 2 meter size. I can resize it to make it a marble plate for the chocolate bonbons and place it on the tabletop. To scale an object, you can use the toolbar which provides a gizmo for scaling, or press S and then X, Y or Z to constrain the scaling on a specific axis. If you want the S keyboard shortcut to display the same gizmo as the toolbar, you may change the default settings in the Preferences Keep Map panel, changing the tool key option from Immediate to Active Tool. If you prefer, you can also write dimensions directly in the Transform panel. Then press Ctrl+A to open the Apply menu and select the Scale item to normalize the scale back to Unity. Next, in the Outliner, I drag and drop it in the imported scene while holding the Shift key. I level the scene to the origin, delete the reference plane used in FreeCAD, and I'll add a backdrop for the scene. To do that, I add a plane, scale it and apply the scale. Then I go into Edit mode, either using the toolbar or faster using the Tab shortcut. This mode allows mesh modification. I select the Edge Selection mode, select an edge, press E to extrude and then Z to constrain along the Z axis. Next, I select the corner edge. I press Ctrl B, drag and add segments using the mouse wheel or pressing S. We can also change the segment count in the Bevel option panel. Now, when I go back in Object mode, we can see the segments. So, we can right-click on the object and select the Shade Smooth. Next, I go in the Material Properties side panel, add a material to the plane and change the color to white. To add materials, I use the BlenderKit library. You may download this add-on from their website and install it from your local drive through the Preferences add-on panel. They have a free version which has many assets available, but they also have subscription plans which let you access their extended library of models and scenes. Links are in the description if you're interested. Once installed, you may search materials and models using their integrated toolbar. First, for example, I'll search a metallic plastic for the case. To apply a material, you drag and drop the material onto the object. If you want multiple objects to have the same material and already have this material in your scene, you do not need to search it again in the library. Instead, select all the objects you want to modify and select as the last object the one with the texture you want. Then go in the Material panel and in the drop-down, use Copy Material to Selected function. Next, I can use a transparent plastic for the lid, wood for the table, marble for the plate, and so on. BlenderKit also provides models and scenes. I can search the 3D model of a plant and drag and drop it on the table as a decoration. Also, for example, I could have used a kitchen scene to showcase this tempering machine. You can also apply images on your models, like for the LCD display. The image was created with Inkscape and exported as a PNG file. To apply it, we need to generate a UV map on our LCD object. So we can open another panel by clicking and dragging a corner of the viewport and choosing the UV editor view. Next, we select the screen, go into Edit mode, select the two faces, right-click, choose UV Unwrap Faces, and finally select Cube Projection. We see those faces appear in the UV editor. Next, we can go in the Object's Material Properties, click on the dot of the base color, select Image Texture, and then open the image from our local drive. Next, in the UV editor, we can scale the faces to the size of our image. Now, for the switch membrane mockup, we can follow the same steps. But to give you a glimpse at additional useful Blender's features, we'll add embossing on the metal dome buttons using the sculpting tool. The switch membrane imported from FreeCAD has a mesh like this, which cannot be used as is in the sculpting mode. So we can go to the modifier panel and add a remesh modifier. Instead of using a detailed mesh, we can set it to the minimum resolution required to have the correct outer shape and then subdivide the surface areas near the buttons. To do that, we apply the modifier and unwrap the new UV map. We select the faces located on the buttons and right-click to subdivide. Then, in sculpting mode, we can add the embossing. Now that textures are applied, let's move on to rendering. You can output either still images or animations. Blender renders what the active camera sees. Press the camera icon to enter the camera perspective or press numpad 0. Press again numpad 0 to exit the camera view. The actual image or animation you'll render corresponds to what you see in the rendered viewport mode. However, when setting up your scene or modeling object, you'll usually work in the other viewport modes, wireframe, solid, or material preview, since they require less processing power for real-time display. Then, you may add extra cameras to get other views of the scene. In this case, to change the active camera, select the new camera, right-click and select the Set Active Camera option, or press Ctrl plus numpad 0. The active camera is the one which has the filled triangle on it. We'll see later how to change the active camera during an animation. But first, let's see how to move cameras. There are multiple ways to do that. The first way is to use the Move and Rotate tools in the user perspective. To see the camera view while moving, you may open another panel and select the camera perspective. And once you're done, you may right-click the toolbar and select the Close Area option. However, this way is not the most convenient. It can be easier to move the camera while you are in the camera perspective. By default, if you move while in camera view, you'll get out of the camera perspective back to the user perspective. But if you select the camera to view option in the view menu, then it makes the camera move and you can pan and rotate using the usual mouse and keys combinations. Alternatively, you may add a constraint on the camera to track an object. That way, when you are in the user perspective, if you move the camera, its orientation will be automatically adjusted to keep the object in the field of view. To do that, you select the camera, go to the Constraint panel and add a Track to constraint and select the object you want to be tracked. In the case of the tempering machine scene, none of the objects were giving exactly the good result, so I added a small sphere as the object to be tracked and disabled its rendering using the camera icon switch in the outliner. Let's now move on and see how to animate the camera and objects. We animate objects using keyframes. They appear in the timeline below the viewport. You can place a keyframe by pressing the dot next to the specific property you want to animate, or you can press I in the viewport or on Properties and Icons in the side panel. If we press I while a camera is selected, multiple keyframes will be added for all its transform properties. Next, we move the playhead, reposition the camera to the next location and press I again. Now, if we play the animation, we'll see the camera move smoothly between the keyframes. If we place the playhead on an existing keyframe and move the camera, we can see the color change in the Properties panel, but the new position isn't applied yet. We need to press I again to apply the new location. Now, it can be useful to hide or show an object during a rendered animation, like I did for the chocolate fork in this animation. Unlike object or camera motion, you can't animate object visibility in the viewport. The effect will only occur in the animation output. So, to do that, you place the playhead where you want, set the camera icon in the state you want, either visible or invisible, then press I. Next, you move the playhead one frame, toggle the icon state, and press I again. And, by the way, thanks for watching. For the lead motion, I put keyframes on the rotation, and for the chocolate fork, I used a motion path with keyframes set on the curve's offset factor property. For this demo, I'll show you how to make a camera follow a path while tracking the default cube. So we can add a path curve, go into edit mode, add and move extra points. Then select the camera, add a constraint follow path, and select the curve. We reset the camera position. Next, we add another constraint to track the cube. To constrain the camera on the curve, select the Fixed Position option. This will constrain the object on the curve with an offset between 0 and 1. You can then animate the offset using keyframes. One last thing about cameras. If you have multiple ones in your scene and want to switch the active one during an animation, first place the playhead at frame 1, select the initial camera and press Ctrl+B in the timeline to set it active. Then move the playhead and do the same for the other cameras. The camera sequence appears at the bottom of the timeline. Now, before we see how to render the scene, let's quickly mention lighting. If you're doing a still image rendering, you may use a 3-point lighting technique, using plain lights for the key light, the fill light, and the backlight. In this case, for the backlight, you can remove the cast shadow in the Properties panel. And you can use the rendered view mode and switch each light on and off to verify their effects separately. Otherwise, you can try to get a lighting that you like by placing multiple spots and point lights across your scene and changing their intensities and colors. Now, to render a scene, you can use the render menu or press F12 for a still or Ctrl plus F12 for an animation. The rendering and output options are found in the side panel. The default engine for rendering is Eevee, which is fast and great for real-time previews, but will select cycles to get realistic, ray-traced result and switch the device to GPU compute. Below, there are sets of parameters to set the rendering quality for the viewport and render. The viewport parameter set corresponds to the rendered view mode. Depending on the performances of your graphic card, you may want to lower further the default settings. Below, you have the render quality and you can switch between final and preview. Preview is especially useful to check that all timings and views are correct in an animation before committing to a full resolution render. Because, as discussed earlier, some properties cannot be animated in the timeline playback. Also, as before, you may lower the quality further in preview mode if needed. Then, you need to change settings in the output properties. You can choose the resolution using the presets or set a custom one. For example, if you want a square output for social media. You also need to set the frame rate and the frame range for the animation. For example, at 30 fps with 360 frames, the tempering machine animation is 12 seconds. To export an image, you can choose the file format you want. And to export an animation, there are also different choices, but you may select the settings shown here for good result. If you don't choose a video file format for an animation, the animation will be rendered as separate images. They can then be merged into a video file using Blender's video editing workspace. Rendering as separate images can be useful in some cases in order to re-render only a part of a long animation or in case there's a problem during rendering.